Hello and welcome to IoT Builders, a live stream where we discuss a range of topics on the Internet of Things, from embedded devices to cloud services, all from an IoT Builder perspective. This is February 1st, and it's also episode 15 of our weekly live stream. Today we have a special guest, Mitko Vasilev, who is an expert in building and running the Internet of Things with over 20 years of experience in technology companies, including his role as the founder and CEO at OA Digital and founder and CTO at Cisco IoT Innovation Center. In Germany, Open Berlin. Mitko has a wealth of knowledge to share on architecting, building, and running planet-scale IoT platforms and products. So looking forward to the discussion today. My name is Dan Gross. I'm a senior developer advocate for AWS IoT and FreeRTOS. And I am joined by my colleagues and co-hosts. Let's bring them on. Hey there.
Oh, hi. How's it going? Yes, I'm Nenad Ilic. I'm a senior developer advocate for AWSD, as my other colleagues here. Looking forward to this chat with Mitko.
Awesome. Myself, same as Nenad and Dan, I'm Syed Rehan, and I'm a senior developer advocate within AWS service team, and glad to have you guys here listening to us and having chat with Mitko.
Hi, my name is Alina Dima. I'm also senior developer advocate in the AWS IoT team, and I'm looking forward to the session today.
Great. Yeah, this should be an exciting talk. Anything we want to mention before we bring Mitko on? Okay, well let's bring Mitko on.
Hello, everyone. Hi.
Hi, Mitko. Nice to meet you.
Thank you for having me. It's a pleasure.
Yeah, I really appreciate you taking the time. Yeah, we've heard a lot about your different interests in IoT and different things you've done. So really glad to have a chance to talk with you. Why don't you give a quick intro about yourself?
Thanks, Dan. So, as you already mentioned, 2 decades experience. I always love to do emerging tech through my entire technical life. So no matter what I was doing, if it was the core business at an enterprise company or it was my own startup, I always love to be on the cutting edge of the technology. And that goes even today. We live in quite exciting times, actually. And as we already have discussed, definitely very hard times this year and next year. So maybe today we can speak about Internet of Things in the evolution in 2 phases: the hard times, 2023, 2024, and then the good times that we were expecting from 2025 up to 2030.
Yeah, that's a great point you make. That companies are changing focus a little bit. We've heard about things like belt tightening and really focusing on operations and that sort of thing. How has that changed IoT? IoT it seems to be a place where a lot of R&D happens and things like that. But maybe there's a shift there, and IoT is now becoming a little more infrastructure based. Or how do you see that evolution?
Well, it was always infrastructure. If you see a decade ago, I mean, obviously it's an advanced infrastructure, so not the typical routing and switching, but you also have protocols, connectivity choices, much more advanced computing, edge, fog, and cloud. But it was always infrastructure. What we see today is actually all the companies, no matter if it's an OEM or it's a an end customer, everyone's going back to the core business. So we see less and less research and development money flowing in, less and less experimentation, and everyone's kind of betting much more on the proven tech stacks, everything which was proven actually to build and operate Internet of Things platforms and devices. So I would say the next 2 years are going to be not so exciting for the emerging tech side of the Internet of Things, but then, I mean, whoever is building today is actually going to thrive in 2025 onwards. So in that sense, we need to get ready.
And do you see this as kind of cyclical? Like, other technologies have kind of gone through similar cycles. But it seems like IoT has, there's more to it because there's so many moving parts, right?
Yeah. Exactly. It's so complex and it's so ubiquitous. And let's say today, if you speak about emerging tendencies in IoT, it's definitely the industrial metaverse. So in many cases, when we speak about metaverse, it's actually Internet of Things with much more immersive ways for the people to communicate with the processes, with the assets, and with all the information. So definitely there is going to be an evolution, and that evolution is now kind of ramping up for the next boom and the next phase. Something that we had back in 2013 when we started the first IoT Innovation Center in Germany. Man, that was like everyone wanted to get in. I mean, that's when we've met with Nenad, and it was like a highway. Everyone just wanted to go and see what it is Internet of Things. Like a decade ago, that was something new: fog computing, edge computing, running applications on the edge, first steps in machine learning. Wow, everyone was so excited. But it's 1 decade. So now everyone is obviously much more excited about industrial metaverse and everything which comes with the metaverse native infrastructure, which is in infancy. But again, it's a new cycle.
Yeah, and IoT, kind of plays in different spaces like machine learning, and you mentioned, the metaverse and things like that. I read something recently that said, IoT is dead, but I think that's not quite right. I think it's maybe becoming actually so pervasive that it feels like maybe it's just everywhere.
Yeah, it becomes a commodity, actually. What I see from different customers I was dealing over the last couple of years, it becomes more and more commodity. So everyone is expecting once they connect the devices or the assets, all the information to go flawlessly inside their data lakes and then to be visualized on their business applications, and everything to become so smooth and everything to become cheaper and cheaper by the day. And it's happening, actually. So it's the commoditization phase of Internet of Things.
Yeah. So, what are builders and developers, to do during this phase, this 2023 to 2024, or whatever the next couple years, have in store? What sort of things should the technology focus be on?
I mean, my view is we are ahead of a brutal 2 years. It's a good time for builders, by the way, because the best time to build is during these mega windfalls, something that we have seen in 2008. Everyone who was building their new product during the hard time actually thrived in 2010 when everything started booming again, all the economies. So if you're a developer and if you're employed, because we have seen mass layoffs lately, build everything that you see there is a customer demand for. Obviously, choose the right technologies for the future, because again, a decade after, there are a lot of tech backpack that the typical IoT developers are carrying around, which came with all the legacy technologies, with all this industrialization of Internet of Things. So keep only the technologies you need for the future, choose the right SDKs, move to the right languages, choose the right platforms, and then get ready for 2025.
Yeah, that's a good that's a good point. That the consortiums, the technologies, the standards, they haven't gone away, and there's still lots of use with all of these things as well. What things come to mind when you think about builders in this phase? What sort of technologies or areas still look very promising?
I mean, that's an excellent question, actually. And for many builders who are in non-tech companies, because what we have seen last 2 years, non-tech companies actually have hired more developers than the tech ones. So they're actually getting much more muscles and talent in-house, and they need actually much less hand-holding from tech companies or startups to go and build their own BYOT, IoT, so build your own Internet of Things. So on the tech stack, definitely, I mean, I wouldn't choose the commodity. Obviously, a lot of people are making money from commodities like connecting devices based on wholesale models, just getting the data out, because it's still a struggle. Like 70% of the time we spend is actually to connect the assets and being able to get the data from the assets, no matter where they're based, on the shop floor or they're in some country across Europe or Asia or Africa. So a lot of people are doing a lot of wealth based on building the commodity IoT and wholesale IoT models. But if you're a tech geek, like I am, you definitely do enjoy to look on the high value applications, anything with much more applications or machine learning or AI inference on the edge. Obviously, it's something for 2025 onwards. But if I'm a builder and I'm a geek, I would definitely bet and see what's next. Like what's going to come with the metaverse native infrastructure, everything which comes with new AI chips which you can run on the edge, everything that comes with autonomous systems, with distributed computing, distributed data. So obviously, do your job, get your money of what you're paid today, but then build for the good times. I mean, that's always my choice.
I like the point you make about a lot of the application development effort is spent moving data, essentially, and but a lot of the time the the topology of these IoT systems depends a lot on connectivity, and so we've seen a really a wide range of connectivity options come up, and that's something that's also very exciting.
Oh yeah. By the way, over the last 5 years, we've got all the extensions of the typical terrestrial connectivity. So some time ago, you always had to use the fiber links or software-defined WAN networks to get terrestrial, get to the cloud, because obviously the public cloud is now the major choice for everyone. So everyone wants to get the IoT data inside their data lakes in the public cloud and then do big data pipelines and whatever BI or processes they want to build. Obviously, everyone faced all the security around enterprise and industrial today with the proxies everywhere, with the firewalls. I can write a book about proxies and how to work with different proxy vendors, because once you have hundreds of thousands or millions of assets deployed over the field, you have to go through all these security enhancements across the connectivity, which are making your life much harder, and also the designs much harder, but part of the enterprise and IoT security stack. Then what we see is the wireless options are booming. So everything around license bands and unlicensed, so lightweight M2M, Cat-M, any kind of 3G, 4G, 5G connectivity is thriving today. You can get a SIM card with 500 megs of data that you can spend for a decade. And you can get it for less than 10 euros. And you have global connectivity in 180 countries with this SIM card. Obviously, we have seen a lot of advancements in Bluetooth, so low energy, Bluetooth mesh, everything around the home. Obviously, Matter is something big. We have seen it at CES. And then something really cool and very close to my heart is obviously the new space. So everything in lower orbit, from broadband to more advanced use cases that are running orbital Internet of Things or edge processing in lower orbit, or even 5G non-terrestrial networks. So you have all these choices now: terrestrial, wireless, or space. Interesting time for the connectivity, but still, at the end, it's firewalls and proxies which define a lot of the work that we have to do.
Yes, one thing that's interesting is like once you have so many choices of like all of these technologies, you can target for your specific needs, but then like how you make sure that you do your management and the of all of that. Like if you have device that connects via 5G but also has Wi-Fi and Zigbee and all that stuff, things get a bit tricky. So I don't know what your take is on that. Like how you make sure that this is all working correctly. You have the right policies and certain identities of like those devices and whatever. Not.
And an excellent question. And exactly this ubiquitous management plane is something that we see, again, a lot of open source and startups and also mature vendors building control planes, spanning across the automation and being able also to do observability of all these assets, no matter where they're based, or applications and data. And definitely what we have seen the last couple of years, control plane plays a key role in Internet of Things for all the vendors, and everyone wants to win the control plane. I mean, from the vendor standpoint, because that's actually is afterwards drives a lot of the choices around applications management, application orchestration, how do you get the data out. And there is like a lot of innovation in that field around Cloud Native Compute Foundation. They released a lot exactly around control planes and expanding a control plane from enterprise standpoint to go to any cloud provider, go on any kind of data center on premises, go to any kind of asset, or even down to the sensor level, down to microcontrollers. And I think all the major vendors now, they have their own control planes expanded outside of their hyperscalers, and that makes everything much more exciting than before.
Yeah, it's quite interesting. Also, I mean, to kind of like support this different protocols and whatever. I think you talked about this kind of like hybrid computing and like different hardware where like all of this can run. I don't know if you want to touch base on that.
Yeah, I mean, ubiquitous computing is another point that we see quite exciting in Internet of Things today and in the near future, because obviously we're getting much more compute capacity, even on the tiny edge. So everything which is running microcontroller and real-time OS. Now we're getting SDKs with integrated machine learning, integrated data management, integrated cybersecurity. So if we look on the computing side, I mean, I always love to work on the edge, and literally the edge, because that's where I see a lot of innovation happening, and a lot of innovation is going to happen over the next decade. So if we split the edge into tiny microcontrollers, real-time, battery-powered in many cases, running on LoRaWAN or Wi-Fi or any kind of cellular connectivity, that's where we see a lot of real-time operating systems thriving. And there was a lot of innovation over the last couple of years. Lately, the most innovation we see there is obviously TinyML and doing machine learning and anything around data processing on battery-powered devices, anything around Cortex M0 Plus and above. Then the light edge is something where we see a lot of innovation also happening until today. We'll see over the next 2 years, but that's where we have seen the movement from bare metal operating systems going to virtualizations with virtual machines. A couple of years ago, Docker, Moby went there and stole getting containers on top of PC size devices was so cool and was solving so many business problems that everyone wanted to go and implement it. Docker was not there as ease of use and kind of flexibility to be able to build applications for the edge and for the cloud during the same kind of methodology. Obviously, you don't want to build it once and run it everywhere because it never works. But you want to have the same methodology for building, having CI/CDs, and then like for both places, and you're going to build the same logic, let's say, for the cloud and for the edge in a very similar methodology. And that's where actually Kubernetes came. So I have a very favorite phrase of mine from 2020, let's say. If the question is IoT, the answer is Kubernetes. So the moment we started seeing K8s and K3s lately going on these light edge devices, that became really exciting for all the developers. Expanding all the innovation they already had on the cloud side with microservices, all the automation, all the ways to deploy and run. And taking it to the very, very small edge was something which blew their mind and my mind too. I mean, I love Kubernetes. I mean, I'm spending the last 3 years actually taking Kubernetes to these lightweight devices. Very exciting times.
Yeah, that is really interesting. The reason why I've seen this pattern is number one is like beforehand, you had to have embedded systems engineer, embedded developers who are skilled with like, building their distribution of Linux and then embedding their applications and then pushing that to the edge. And then there was like this clunky process of development. And then on the other side, you have those kind of developers that are familiar with the cloud and CI/CD and how to like express your infrastructure in like YAML. And the people from embedded are kind of like you rarely find those expertise nowadays. And on the other side, the other field is booming, so you can have a lot of those engineers as well, and then allowing them to use the same tooling and the same methodology to kind of like build those applications, services, whatever it is, and deploy them on the edge is something that's like as you said, will unlock definitely quite a lot of new capabilities, new features, and benefits for the end customer, right?
Yes. I think most of the customers already have decided to refactor their applications on the edge to Kubernetes. So over the next 2 years, no matter that it's going to be hard times, everyone's going to run Kubernetes. Like in 2 years of now, most probably manage Kubernetes because it's not that easy to operate it if you just go and get the vanilla one. But manage Kubernetes on the edge, everyone's going to run it in any shape. So 2024. Everyone is Kubernetes based.
One thing I noticed with the customers is that if you have like a control plane that's basically in the cloud, and then you extend your cloud with the nodes that are on the edge, you then start to get a lot of bandwidth. And then there are some requirements when it comes to bandwidth constraints. And I seen people kind of like reluctant to adopt Kubernetes, but then going to some more lightweight technology like Nomad and WebAssembly as well. I mean, have you noticed that kind of pattern as well?
Also something which popped up over the last year, because I see the comments from Shabazz. Exactly, the tiny and the light edge, they've got enough horsepower now to run advanced applications also without containers. And everyone is falling in love once you start working with anything around WebAssembly or Nomad or Acri from Cloud Native Compute Foundation. Everyone is falling in love how easy it is actually to make worker nodes based on these runtimes, place your applications, place your application loads on top of these constrained devices, which are not so constrained because, I mean, the modern sensors, they're relatively cheap and they actually can acquire fast data, and many of them, they have multi-core kind of MCUs, so they're powerful enough. And with WebAssembly, Nomad, you can just go push the data, push the operations, push the application to be kind of executed on these small satellite compute devices, and then get the results to more light or heavy edge, where you have multi-core CPUs and you have more heavy databases, or you want to do some more heavy processing. So I'm a big fan of WebAssembly myself, and I'm looking to go to the
Mm,
first WebAssembly conference now in March, actually, in Barcelona,
nice.
because this is going to be just going exponentially up.
Where do you see the applications, working with WebAssembly? Do you see like scripting languages being used in these um, sort of sandboxed environments, or
Mhm.
how do you see the I guess application developer, taking advantage of that? I mean, does it mean that we can um, there there might be a lot more developers able to write embedded
Mhm.
applications as a result? Is that what you're seeing?
Yeah, I mean that's completely right, Dan. Actually, because with the modern tools, I mean you can develop applications, you can develop UIs. I mean there are frameworks like Blazor, as an example,
Mm,
where you can develop a responsive UI. You can distribute certain part of the compute to be done on top of the microcontroller, certain part to be done on top of the light edge or heavy edge device, or even the cloud. And that can be done also from generalist developers, which is a huge step going forward, because uh, finding experienced embedded developers that actually can work directly on the embedded side on the RTOS with C or C++, it's getting harder and harder nowadays. So
mhm. So you
WebAssembly,
could see
yeah.
Python and JavaScript and other things running in these environments, right?
Yeah, because these microcontrollers, they're getting quite powerful actually. Some of them are like 4 cores, 133 megahertz.
Sure.
So Python
Yeah,
is
even
like,
the newer Raspberry Pi Pico is a dual
oh yeah.
core MCU, right? And that's even a rather cheap cheap SoC.
Yeah.
Yeah, and it's just not the dev kits. Any kind of temperature sensor you get today, there is enough compute actually to go and run applications and do sampling of the data or do sort of machine learning model inference on top of the
Mm.
sensor itself, which is amazing.
But even this, I mean, on top is that those applications. I mean, we talked with James on one of the podcasts, and he was talking about Rust, and he was explaining that, like, I mean, from my perspective, like, I know C, and I know how that C that I write will become assembly,
Mhm.
and I'm targeting a specific instruction set. So I write C like I'm writing assembly or something like that. But he explained to me that nowadays the compilers are much better than any human being
Yes.
writing an assembly. And even though like Rust has like a high level expressions where you have like
Instruction.
iterators and whatever not, he said
Yes.
that he wrote two different versions of Rust, like the where one compiled, which the one that used this high level semantics
Mhm.
compiled to a more efficient code that is then running on a microcontroller. So the same thing that, I mean, I was following up on this. The same thing is happening with WebAssembly, even though you have like high level languages like Python, JavaScript, even
Mhm.
Java can be then compiled to assembly. It is so efficient that it tries to minimize the number of instruction set used and all that kind of stuff, and the memory and all that stuff. So this is something that it would be really interesting to see and compare in the future. So
He's completely right. I actually have spent some time with the founder in the new space tech, and he's also a big fan of Rust. So we have also big discussion in regards to Rust in safety critical applications and how it's almost getting now certified. So you'll be actually to use Rust, and as you have seen, this really optimized machine-based compilation for different architectures, as to run Rust on top of satellites in lower orbit. And it's done better with the machine than the human being. I mean, we're not speaking about Codex engine, which is optimizing and be your kind of pair programmer. We are speaking about like a full optimization by the IDE to run more efficiently on the target architecture. So it's a good bet.
Yeah, and yeah, especially these I think Rust is getting a lot of attention lately because of the safety aspects.
Yes.
And that's pretty interesting. I don't know that it's any easier necessarily to learn and write applications for than C. But it does get you, out of some trouble with memory bugs and things like that, right?
Yeah, exactly. And they're machine driven, so you don't require a developer with 15 years of experience to build a safety critical code.
So you've touched on this satellite, technology that's getting more accessible. Can you talk a little bit about that? It seems a little bit like science fiction, but it's actually sounds like it's something that people can start to actually play with today. Much like LoRa or things like that were a little bit um, difficult at first, but then became very pervasive because dev kits were available and things like that. Sounds like some similar things are happening with satellite.
Exactly, because if you want to get ubiquitous connectivity, sending data and observability from lower orbit is key, and any kind of orbit, actually. And what we have seen now, all the major hyperscalers already have ground stations as service offerings. There are also space SDKs, so you can actually get an SDK to be able to address the satellite, being able to get data, let's say images, then process the images to understand anything in regards to agriculture or very precise weather forecasting. It's still not so easy. So it's still not ready for enthusiasts. And that's another discussion that we had with another founder, actually last week, around getting these enthusiast kits to build your own ground station, being able to go and subscribe to specific satellites, and in a matter of, let's say, credit card transaction of $9.99, being able actually to experience lower orbit and new space. It's not there yet, but it's definitely something very interesting for the good times in 2025, 2030. I see a lot of interest in new space today, still an emerging tech, but looking also on the budgets and how everyone is going back to the core, maybe the next 2 years is going to be stalled a little bit. And then, but whoever is building during these hard times is actually going to thrive, as we already mentioned. So everyone who is dealing with space SDK is dealing with lower orbit images, high bandwidth applications, IoT from orbit. There's going to be a market ready to adopt in 2 years from now.
Yeah, that's pretty exciting. And what are some of these use cases? You mentioned, weather prediction and things like that, but there's also bandwidth and other things that people are looking towards, right?
Yeah, getting broadband to areas which were not covered before changes the life of people. And then there are multiple, let's say, just an example, agricultural use cases where you have tanks collecting water from rainfall. And if you want to measure the amount of water you have actually in the tank, so you know how much to use at a certain time, you obviously have two choices. Either go and get connectivity to the tanks, then retrofit them with ultrasonic sensors, as an example, or any kind of sensor which actually can measure the water level. And then support all that infrastructure on the ground. And think about it, it can be somewhere in Africa, or it can be even in rural Germany, which is not an easy place to get connectivity in. And so much easier is actually to go and measure the tank from space with images, etc. Just you get near real time understanding how much water is there, and you can build all the pipelines, all the alerts, all the BI actually to use the water based on the actual amount without any kind of retrofitting on getting connectivity to the tank. It's a game changer.
Yeah, so that's a great scenario. Having a connectivity through this LEO, low Earth orbit satellites, giving you a hop directly into the cloud. Do you feel that in terms of the management of the control plane of these devices as well as data, can we rely on real-time safety critical applications by using these, knowing that obviously there might be latency issue because obviously I'm talking Leo, What's your thoughts on that?
I mean, latency in many cases is not that bad as compared to the latency to a typical broadband in Germany. I love to give it as an example because I was living in Berlin and getting internet connectivity at home was such a pain. So, and also for the innovation center, we actually had a data center attached to it. So getting fiber optics in Berlin, in the city center, takes months. It takes forever. So, and lately, I'm using a lot of actually lower orbit over the last 2 years, and then getting this high bandwidth for my applications for anything I want to use, literally instantly, and with a pretty decent latency actually. So you can have video, you can have high frequency sensors actually sending data. You can bundle them. What I have seen actually, companies bundling, let's say, 6 terminals, and then they're getting 1 gigabit a second connectivity. Think about it, such a game changer if you need to extract huge amount of data, if you need to get, let's say, data from a big historian into a factory where you have the data for the last 20 years. And you obviously have the choices to go and drop any kind of data box, hard drive to get the data, and then a tractor to drive it somewhere. But you can also get this gigabit connectivity over lower orbit, 6 terminals. And here you go. You're connected. You don't need to upgrade your MPLS. You don't need to upgrade your kind of WAN connectivity. And in many cases, you can actually connect via orbit directly to your own private virtual data center in the cloud. So your cloud is always getting a single hop away, no matter where you're based.
Well, I think isn't this technology is a bit too early for mass adoption, because
Yes.
obviously the cost implication is there. We cannot commoditize it. Yes, it will be good for enterprises and corporations. But what about let's say somebody is basically doing a mission critical work in the middle of Sahara Desert. He won't be able to utilize that because we're not at the stage of matured LEO orbit satellites,
Yes.
right?
Yeah. I mean, if there is cellular coverage, what we've seen, there are so many IoT aggregators today that actually can provide you with a SIM card. And if you have a cellular wireless connectivity, you can roam in between countries, no matter if you're in Africa, in Asia, China, US, single SIM card, single eSIM, with a pretty decent pricing and a lot of flexibility actually to bump your bandwidth, provide you more capacity if needed. So I see a lot of kind of 3G, 4G, 5G, lightweight M2M and Cat-M choices if there is a terrestrial network, also for safety critical applications.
Yeah, that's a great point.
Yeah.
I mean, while we having you mentioned about the data in a historian, let's say, for example, this is where we're talking about having a data at the industrial edge and
Yes.
having the data transferred over to the cloud. Switching up a gear, are you seeing that where in terms of connectivity to the devices to the cloud, where the main purpose is, because obviously without IoT there is no data, and data is basically synonym with IoT. Having that in effect, where are you seeing more traction in terms of when it comes to on edge or on the cloud, or simply just analytical data coming to the cloud? Where are you seeing the attractions, and where are you seeing the trends popping towards? Are you seeing edge compute then sending the data by removing the noise, or sending the raw data and then having the noise removed on the cloud?
I mean, in most cases, it's raw data still. I mean, if you ask me a decade ago when I was starting with IoT, I would think, oh, we're going to do everything on the edge, because on the edge you see like 95% of the data. And then we're going to just ship the important insights and any kind of alarms and alerts upstreams. It did not happen. So in most of the cases, people are just sending a lot of unstructured data still up to the cloud, and then getting with all the bandwidth constraints, any kind of throttles of ingesting data from IoT pipelines into big data pipelines. So there is still a lot of complexity actually getting the data. As we said, 70% of the time today we spend to get the data out from the assets, from the sensors, up to the Snowflakes, Databricks, or Mongo outposts of the world. So you can put it in the the modern data lakehouse, and then after it's in Parquet format, different data engineers, data scientists, software engineers, actually, or business users can consume that data. So still a lot of raw data, a lot of non-contextualized data, a lot of data that needs to be refined on the cloud side, which drives a lot of cost, not only for sending, but also to refining and cleaning the data afterwards. But that's the world we live in. And also it's an opportunity for many startups that we see in that stage, actually looking to contextualize, to normalize data on the edge for heavy industrial assets where you have all these historic data in historians, SQL databases, in Excel files, any kind of text files. So being able to get that data, add context, clean up, fill up missing fields, and then build a steady IoT data pipeline up to PubSub on the cloud side, and then being able to ingest it into the big data pipeline inside up to the BIs.
Great. Are you seeing from startups where we actually have a lot of legacy protocols, such as, for example, SCADA? Are you seeing traction from the startup perspective where we are seeing builders adapting or providing connectors for these SCADA proprietary systems to create the ease of path for the data into data lakes within the cloud?
I mean, it's not like a super thriving field. It's not like startups using ChatGPT, but there are some actually finding this niche of translating between proprietary protocols and any kind of OPCDA or any kind of, as you mentioned, protocols which are used across SCADA networks. Being able to go and reformat the messages in something which can be consumed on the cloud, so they can put it as a paywall on top of MQTT Smart Plug B, or even OPC UA. So it's an interesting field. Not many startups. It's a hard one. Long sales cycles. I mean, the industrial companies, at least until now, they really love to do a lot of proof of concepts. And that's the big gap in between proof of concept pilot and actually paying production. And in industry, it's kind of long, and a lot of startups actually had hard time to do that.
Right. Great.
Actually, I want to also ask you a question. It's not really related to data so much.
Mm-hmm.
I'm going to go back a little bit to device management again. Do you think that in the good years of the future, like 2025 onwards, there will be any breakthrough in, for example, OTA? Because it seems like nowadays, with all the standardization around device management and open protocols and open specs,
Yes.
firmware upgrades are still difficult and problematic, and some devices, like for example devices you wouldn't expect to, right, like modem routers, which are quite powerful embedded devices if you think about it, you still can't get incremental upgrades on them, so you're still getting a full image. Do you see anything sort of evolving in this space?
It's evolving also from legal standpoint, because I don't know if you monitor all the legal legislations in IoT, but you need now to have a path. Actually, once you ship the device, you need to have a plan how this device will be upgraded for next decade. And there are legal implications if you don't do that. So people are going to go to jail if they don't do proper upgradability of IoT in the future. It's part of the EU legislations. On the technical side, as you mentioned, obviously OTA is a big topic, from microcontrollers down up to operating systems, and obviously embedded hypervisors in between both. It's a hard topic. Some of the industries, like the automotive, they had to do this big bet because Tesla was pushing everyone actually to solve the OTA for automotive. And there have been a number of acquisitions. And I mean, automotive, I think they have solved the OTA to a certain extent. But the general industries, the general OTA usage is still very hard, actually. But maybe the legislation and the possibility that someone can end up in jail if they don't do proper upgradability is going to drive actually OTA and the whole device element asset management to the next phase.
Sounds interesting. What would you think some of the challenges? I mean, why is it this hard?
Various reasons. I mean, operating system differences, runtime differences, application differences. I would say it's a very complex scenario because we have all that flexibility, and with flexibility, you obviously have these big metrics of choices, and everyone's thinking incremental upgrades are easy, and then you just see like GitHub the other day, they have changed the compression algorithm, which broke so many CI pipelines because just the checksums were not matching. So these simple things, I mean, they're triggering like the butterfly effect. So someone is changing the compression on one side, and then your OTA upgrade is failing, and you're getting audio alarms in your CM system only because of that small thing. So kind of quite complex field. But if it's standardized, let's say as automotive, if you see the major German automotive companies, because of the push from Tesla, that everyone now has a working OTA, by the way.
Nice.
Yeah, and it may have to do too with versioning is always difficult because of, especially with consumer products, because you ship your consumer product and it sits at the store and people buy them at different times. Meanwhile, you're producing different firmwares and updates, and you may be on 1.2 by the time the product is actually purchased and fired up for the first time, which is still on 1.0. So managing those versions and when devices are updated or when they can be updated is quite challenging, I think.
It's challenging in a data center. You rarely have like N-2 upgrade path. Even on the data center side, where you have unlimited compute, unlimited bandwidth, unlimited energy, and think, as you said, something stays on the shelf for 2 years, then it plugs in. The DNS names are different. The key expired. Everything is different now.
Yeah, and I think there's also a lot of thinking when you're thinking about this kind of workflows, like the firmware upgrade workflow itself. There's a lot of thinking that it can be device driven, that the device can actually drive the entire workflow, all the different sets of operations that need to be performed as part of a firmware upgrade. But actually, the value only comes when you are abstracting away from allowing just a device to do all of this, right? So imagine you'd build this workflows in the cloud, and you'd interact with a device and interact with other systems, and also build this sort of observability on top.
I mean, distributed control plane is definitely the future. It's something that we are going to see more and more often. So it started with Kubernetes, where you can actually have the K3 or K8 control node. And you can do a lot of these decisions and a lot of these automation flows. And I mean, you can use all the plugins and extensions of Kubernetes to do a lot of that stuff on the device itself. And the device is actually taking all these decisions. It's just a matter of time of actually getting these kind of control capabilities with an easier use, also down to small devices like microcontrollers. But it will happen. I'm with you. It needs to be device driven.
So, also looking ahead to the good times, as you mentioned, I think you touched on briefly how the metaverse is growing, and really how IoT plays into that. Maybe talk a little bit about how you see that that sort of convergence.
I mean, starting, let's say, March 2022, so almost a year ago, 50% of my time I'm investing in the metaverse topics. I mean, the metaverse infrastructure topics. Because, I mean, once you experience it, I'm not speaking about the stuff with the crypto and obviously with the NFTs, etc. It's a different field of people dealing with it. But taking into account the real metaverse, where you can actually get people in the loop within the processes with much more immersive interfaces and getting much more automation and autonomous systems and grasping information directly from the devices, being able to process devices. So this metaverse native infrastructure is something that I'm investing like 50% of my time for almost a year now. Because for the good times, my big bet is when we spin out of the hard 2 years ahead, everyone would be looking into more easier way to operate, more effective way to operate, much bigger, so-called autonomous processes, so like dark factories almost, where you can have this heavy automation. And that's where this metaverse native infrastructure is going to go and play a key role, because metaverse today, it's really easy. If you have high power CPUs and you have these headsets for $4,000 and you have unlimited bandwidth, you can get all the data from the devices. You can go do simulations, do 3D modeling, visualize the data, or use 2D with any kind of business intelligence interfaces. It's really easy to be done in the lab, but since metaverse, by far, that's my view, which may be right or wrong, metaverse is the future of IoT. So we're going to speak about metaverse builders in 2025 or 2026 with you. So the metaverse builders in 2025, they'll need an infrastructure actually to being able to go communicate with the machines more effectively, bidirectionally, much more open standards, much more open protocols, consistency of the way that they're communicating, then having a meta layer where they can work with the data, where any kind of simulations, visualizations, any kind of digital twin, live digital twin representation is done. And then having this immersive experience for the operators or for the end users to actually interact with that middleware in between the machines and processes, etc. And obviously, you need a new thinking. You need this new infrastructure. And we have the compute today, by the way. In many cases, we have the connectivity. We don't have the software code for everything. Definitely, there are a lot of things that needs to improve on the software side, much more interoperability. But definitely, this is going to be also 50+% of my engagement over the next 2 years.
Yeah, that's fascinating to think about really expanding the notion of digital twins and into AR, VR spaces, and really expanding out the definition of the metaverse. Really, it's pretty amazing if you think about all the modeling and data to back that, and how that that could be quite expansive.
Yeah, but that's the future. It's the automation. And I mean, you don't need always to have VR, MR. You can also have any kind of interface on top of a desktop PC or
Right.
laptop, but you have all the information represented in much more immersive way for you to communicate with the machine. So the processes and the machinery actually can learn from human in the loop until we achieve the full automated autonomous loops inside the industrial process.
Very cool. Very cool. Let's see. So, any other topics? I know we're approaching the top of the hour. We've got a few minutes left. Any other topics we didn't actually hit on? I know we've talked about a lot of things here. Anything we missed that you'd like to talk about, or even ask us about, anything like that? Anything that you find just really cool and interesting that is worth mentioning?
I mean, definitely the cool things are in regards to a hybrid computing. I mean, if you're a developer or if you're a geek, thinking about actually expanding the things you're building on the cloud, also on the very, very edge of the network where the real world starts. And I see a lot of innovation on the chip side, which is happening even today with ARM, RISC-V architectures. AI core chips. So there are so many startups now building AI chips. It's unbelievable. I mean, there is a list, and I was looking like 50, 60 startups, and everyone is experimenting with everything possible actually to make the devices very smart with a minimum amount of energy, and then being able to go process data, being able to actually to have a really good sensing of the physical world, and giving the devices like machine vision capabilities, decision-making capabilities. So I would say this hybrid compute is extremely exciting and gives limited possibilities for developers.
And that ties into, even edge sensors and things too, where sensors, can be, you can bring AI into sensors. And so instead of just getting values off of a sensor, you could actually get more meaningful data off of sensors from AI. That's pretty interesting to think about hybrid compute at the edge.
Yeah, you can build entire autonomous assets where you have all the sensors sending the data to one bigger compute unit on the edge, and then that bigger compute unit is actually already have downloaded the pre-trained model. You just do the inference of the model based on the living conditions, and then you have this autonomous asset, which could be a tractor, which could be a vehicle, it could be an automated guided vehicle, it could be a crane. It could be a power plant. So everything can become autonomous asset thanks to all that innovation in hybrid compute, where you can have computation and AI running basically everywhere.
Wow. Yeah, we got a comment on our on the live stream here that from Shabazz 123 that it is great that modern sensors are relatively cheap and can acquire fast data, which can be processed. Low-hanging fruit, but often still needs to be done with customers. So I think that's the key too, is where are the use cases, where are the customers, and what do they need that needs to be built, right?
Yeah, I mean, always listen to the customer. That's my lesson from my failed startup, because I love emerging tech, but you always have to listen to customers. And what I see now with these hard times, everyone wants to retrofit the assets they already have. So everyone wants to get the maximum out of the equipment or machinery they already have installed. So 2023, 2024, retrofitting, big thing, big business, optimizing processes, minimizing any kind of downtimes, because you cannot get certain parts because they cannot be produced or they cannot be bought anymore. So there is going to be a lot of retrofitting over the next 2 years. And then in the good times, we're going to build these new autonomous assets running on the edge in all the different directions, on the ground, in the air.
Amazing. Yeah. Looking forward to it, actually. There's a lot to do, a lot to build, and IoT is certainly not going away anytime soon.
Oh, yeah. I mean, I love the discussion around, as you said, someone wrote somewhere that IoT is dead. It's not that. It's obviously getting commoditized, but IoT is there, live and kicking. Obviously, there are new ways like metaverse taking over a lot of these IoT aspects that we know from the near and future and past. But it's part of the technology cycle, and that's where the developers actually have to invest, like keeping up the cash flow for their needs, but also invest to what's coming. And I'm mentoring a lot of different engineers, developers, etc. And I always am telling them something. So make sure you're the person to go to for something which makes money today. So it's something which actually is in high demand today, and everyone knows you that you're the go-to person for that specific tech. And as an example, today is going to be Kubernetes. So everyone who thinks about Kubernetes on the edge is going to go to you. I mean, you are the owner of that topic in the company, across your entire ecosystem. Everyone knows you. But spend 25% of your time, which is something which is upcoming. Start building your brand, start building your know-how, your hands-on experience with this upcoming thing. And I mean, for me, as an example today is Kubernetes on the edge, and then upcoming is the metaverse, native infrastructure. So that's what I'm always telling my developer friends.
That's awesome. Thanks a lot for taking the time, Mitko. Really appreciate it. I think we're out of time here, so we're gonna say goodbye for this week. But we'll be back next week. Thanks, Alina. Thanks, Syed. Nanad had to drop, but thanks, Nanad. This was a really great discussion, and again, thanks so much for taking the time.
Thank you, everyone.
Thank you.
Thanks.
All right. Talk to you next week.
Thanks. Bye-bye.
Thanks. Bye.